Hello and welcome to Add-on. So, have you ever wondered what keeps the cyclotron one of the most popular particle accelerators, like from taking particles to ultra high speeds, like almost the speed of light? So, today we are going to dig deep into the limitations of the cyclotron, breaking down every reason it falls short of reaching those incredible speeds. So, let's start with the basics first. A cyclotron is a machine that accelerates charged particles like protons or electrons in a circular path using an oscillating electric field and a magnetic field. But here is the catch. There's a limit to how fast it can make those particles go. And it's all got to do with the Einstein's theory of relativity. So let's check how. Why cannot a cyclotron reach the speed of light? So let's answer that question step by step. When particles like protons or electrons gain more energy, their speed also increases, right? Their speed also increases with the gain of more energy. But here is what it gets interesting. So as they speed up, their mass does not stay the same. It actually starts to increase. Now, the relation for this mass increase is given by the equation m equals to m0 by root under 1 minus v square by c square, where m is the mass of the particle at the higher speed and m0 is the rest mass or the mass it has at rest, and v is the particle's velocity and c is the speed of light. Now, the interesting part is in this square root in the denominator. As the particle's speed v gets closer and closer to the speed of light, the whole fraction b square by c square approaches to 1. And as it approaches to 1, the value inside the square root gets closer to 0, which causes the mass m to increase dramatically. Alright, so how does this mass increase affect the cyclotron? Well, here's the key idea. In a cyclotron, particles accelerate by staying in sync with the oscillating electric field that changes at fixed frequency. But when the particle's mass increases, it messes with the synchronization. Now, think of it like a dancer moving in rhythm with music. Let's check the diagram here. So, think of it like a dancer moving in rhythm with music. Like a dancer is dancing. If the music suddenly speeds up or slows down and the dancer moves does not match anymore, they lose the sync. Similarly, as the particle's mass changes, its speed and timing do not line up with the cyclotron's electric field anymore. This loss of sync means the particle cannot be accelerated any further because it's no longer in phase with the electric field oscillation. Now let's look at a specific case with electrons and protons. So electrons are much lighter than protons. So at any given energy level, they will move faster than protons do. Since they reach higher speeds quicker, they experience a more noticeable increase in their mass, even at relatively low energy. So as electrons speed up and their mass increases, they can no longer stay in sync with the cyclotron's electric field. As they cannot no longer stay in sync with the cyclotron's electric field, their orbits fall out of phase. And that's why it's even harder to accelerate electrons in a cyclotron compared to heavy particles like protons or deuterons. So to sum up, we have here the limitations of the cyclotron, which is relative mass increase, which means as particles accelerate and approaches the speed of light, their mass increases. The increase disrupts the fixed frequency of the cyclotron. The particle cyclotron's frequency can be significantly altered by changing its mass when the energy is very high. No further acceleration will be caused as particle orbit won't be in oscillating potential field. And the next limitation is loss of synchronization. This means the mass increase throws the particle out of sync with the oscillating electric field, meaning it cannot keep accelerating. Because electrons are lighter, they reach speed closer to the speed of light sooner than protons or deuterons, making them even harder to accelerate in cyclotron. And there you have it. The cyclotron is fascinating for accelerating particles up to the point, but thanks to the relativistic effects and Einstein's theory and mass changes at higher speeds, it has its limits. Hope you find the explanation helpful. If you want to dive deeper into particles physics, keep watching more video. Thanks for watching.